This video covers some principles of data and analysis for program evaluation. The first question we want to ask when we're thinking about data and analysis for evaluation is what kind of data will empower our stakeholders to make good decisions? In this video, we're going to talk about 5 different types of data. We'll talk about absolute results, results relative to a benchmark, relative results focused on change, relative results focused on a comparison, and correlation. Absolute results are numbers or values that are typically presented without much comparison information. We also often call these descriptive statistics. Some examples of absolute results are things like the number of people participating in programs or services, the percent of people participating in programs or services, or data like post-test scores for people who participated. Notice that all of these are just data, and there's no real information on whether the outcomes are good or bad. Another kind of data is data that's relative to a benchmark. Here, you still have a number or percentage of people participating in programs or services, but you would compare that with a goal or benchmark in order to add an evaluative quality to the data. These benchmarks can be determined internally or might represent targets or standards set by outside groups or comparison with others, including competitors. Some examples of data that is relative to a benchmark would be the number of people participating in programs or services as compared with capacity, the percent of people participating in programs or services compared with a target participation rate, or something like an average post-test score compared with a cutoff that's identified for determining what makes a good score. Relative results focused on change are data in which pre-treatment observations are compared with post-treatment observations. Here, we're really focused on change within the subjects. We want to understand what the effect was of the treatment on the subjects as a whole. An example of relative results focused on change would be gathering information on the number or percent of people who showed positive outcomes before participating in a program, and then comparing that with the number or percent of people who show those same positive outcomes after the program. Relative results focused on a comparison are data in which results from one group are compared with results from another group. Most of the time, that's a comparison between a treatment group and a comparison group, or if you're doing a true experiment with random assignment, a comparison between a treatment group and a control group. The main point is that the focus here is on the differences between groups. An example of relative results focused on comparison would be comparing the number or percent of people from a treatment group who received programs and services with the number or percent of people from a non-treatment group who also demonstrate positive outcomes. What you're looking for here is a difference between the average outcomes of the treatment group and the comparison group. Correlation is when you measure or observe multiple variables simultaneously, including an outcome variable, and observing which of the variables appear to trend with the outcome. An example of a correlation approach would be something like identifying which factors, like work variables, life experience variables, or wealth, might have an impact on an outcome such as happiness. In a case like this, you would gather information on all of those things at the same time, and then use statistics to determine which things trend together. Each data type has its own analysis type. When you're looking at absolute results, you don't really need a lot of analysis since there's not really an evaluative component. When you're looking at data relative to a benchmark, you would use a one sample test that compares the data that you gathered with your benchmark. If you're looking at relative results focused on change, you would want a paired test that compares the pre-results with the post-results. If you're using relative results focused on a comparison, you would use a two-group test where you can compare between groups. And finally, for correlation, the most common type of analysis is regression analysis. A little statistics refresher may be helpful. All the types of analysis we just discussed will produce a statistic called a p-value. The p-value is not the most important statistic that will come out of each of those tests, but each one will produce a p-value. And it's important to remember that a p-value below 0.05 suggests that there's some sort of difference in your analysis. Which difference we're talking about will depend on the specifics of your project or analysis. Those differences, though, might be between the sample and your benchmark, between the pre-test and the post-test, between groups, or between a slope estimate in a regression and zero. A quick refresher on regression analysis may be helpful as well. We can use regression analysis for correlation, but it can also be used to add control variables to the other kinds of comparison tests we talked about. In order to do that, you would create a binary variable that indicates group, such as pre-test versus post-test, or treatment versus comparison. You can then use that binary variable as an independent variable in your analysis and add other control variables as necessary. It's also useful to remember that the type of dependent or outcome variable that you use affects the regression model that you should select. For interval outcome variables, you should use linear regression. For binary dependent variables, you would use binary logistic regression. For ordinal dependent variables, you would use ordinal logistic regression. And for categorical dependent variables, you'd use multinomial logistic regression. The other option for categorical dependent variables is to make sets of binary variables for each of the outcomes that you've identified and run binary logistic regression for each of them. There are three more types of data analysis that are definitely worth mentioning here. The first one is time series and interrupted time series. The second is regression discontinuity. And the third is difference in differences analysis. Time series and interrupted time series analysis are especially useful when you're tracking the same information over a long period of time. Regression discontinuity analysis is really useful when your program has an eligibility cutoff. And difference in differences analysis is useful when you're comparing rates of change from pre to post or across groups, rather than just single values before and after or across groups. Thanks for watching this video on evaluation data and analysis types.